So question 4 is a Hass's law problem. So question 4 here says that consider these reactions where M represents a generic metal, and it gives you all these formulas, and you have to determine the enthalpy of the following reactions. So let me write this down. Let me write this down in blue. So it says here it's 2M plus, this is our target, plus 3Cl2 gas yields 2M Cl3 in solid. So we want the delta H, the enthalpy of this reaction, right? So this is a grade 12 problem actually. So I accidentally put a grade 12 problem here, but it's okay. We can look at this. For those in the U.S., you probably seen this before. So we have 4 chemical form equations we can look at. So this is 2M times S plus 6HCl aqueous yields 2MCl3 aqueous plus 3H2, and then the enthalpy of this reaction, I'm going to move this over, would be delta H would be negative 569 kilojoules. We have HCl is HCl gas, yields HCl aqueous, and then the delta H for this one is negative 74.8. We have H2 gas. Let me shift this over. We have H2 gas plus Cl2 gas yields, we have 2HCl gas, and the delta H for this is negative 1,455 kilojoules. And we have finally MCl3 solid would get, I have MCl3 aqueous, and this is delta H equals negative 405 kilojoules. Okay, so we have all of these things written out here for us. This here is in kilojoules, sorry, negative, whatever. Okay, so what we have to do in the Hess problem is we have to make this target. The blue one here is our target formula, and it's comprised of these secondary or these other chemical formulas. So let's look at I'll color coordinate this for you. So let's look at the first guy here. So this is, I need 2MS, right? So I have 2MS here in our left side, which is good. So they all have to be on the same side as well. So some sort of metal, generic metal. So 2MS, good. And then I need to have, so that's good. So I need to use this first equation here, 2MS, because that's good. Where can I find 3Cl2? I can find 3Cl2 in the reactant side with this formula here, right? But I only have 1 Cl2 here. I need 3, which means I have to multiply this entire equation by 3, which means I have to multiply the enthalpy also by 3. So let me multiply here by 3 first, and let me get the enthalpy here is negative 1,845 times 3, right? Which is negative 5,535 kilojoules. Okay, so we have that here. So now this here becomes this is 3 now. This here is 3, and this here is 6, right? And because I'm multiplying this entire equation by 3, so this is 6 now, and that's going to get me. So I can delete these brackets here. Here, and so I multiply by 3, right? And so which means my enthalpy multiplies by 3 as well. So that's good. I have 3Cl2 now, and then I need to make 2 MCl3 solid, right? 2 MCl3 solid. So I see that my MCl3 solid is on this side of the reactants. So I want it to be a product side, which means I have to flip these two guys. I have to flip my aqueous one to go on this side, and my solid to go on the product side. So in order for me to do that, I simply just flip the enthalpy sign here. So this here I'm going to multiply by negative 1, which is 405 kilojoules. So now what I can do is I can rewrite this equation here, and I can flip it to say that this is MCl. So this MCl3 AQ yields MCl3 solid. And I actually have two of them. I need two of them here, which means I have to multiply this entire equation by 2, right? So if I add a 2 here and a 2 here, then I would have to multiply this enthalpy here by 2, which would give me, let's see, this is 910 kilojoules. Okay, sweet. So I did that. So now I've accounted for all these things, but I have some side reactions I need to account for, right? I have two metal solids here. I'll do this in red. What do I need? I need so what I have so far in terms of my target is I'm gonna do the target stuff in red because that's what we need, right? I need this, and this, which I can get from two metal solids here. I have 3 Cl2 here, and I have 2 MCl3 solids, right? So this is the target equation I need, 1, 2, and 3, right? So let me label this 1, 2, and 3, 1, 2, and 3. Actually, the numbers might mess you up here, actually. I'm just gonna, I'm not gonna write the numbers here. So, and what I also have is I have some side stuff, right? In order for me to use the first reaction here, I have to, I have some HCl being produced, and I also have some hydrogen gas and some other stuff here. So, what that does is, if I combine all these equations together, what that means is that if I have a reactants onto the side, and if I make it in my products, it cancels out, right? So, for example, I've made here my reactants here for equation 4 was 2 MCl3s, right? And if I make 2 MCl3 in my equation here, this can also this reaction and this reaction here, because this is in the product side, this is the reactant side, is going to be used up in my general reaction. So what I can do is I can simply just cross these two out because it's being made and being produced. Same thing for my hydrogen gas. I believe this, I forgot the state here, but this H2 is in gas form, which means I have 3 H2 on the reactants and 3 H2 on the products. So these also cancel out, which is great because I don't need those in my general equation. I don't have my general equation here, right? The goal is to cross out all the things that are not my main products here, the side products in this case. So all I'm left with is I have to deal with HCl AQ, HCl grams, and HCl AQ on this side, right? And as I can see here, I have an HCl gas on the side, but I have an HCl AQ on this side. And so I can't cross these two out, but I can cross out this grams here and this grams here only if I multiply this here by 6, right? So I need to multiply, I need to multiply this entire second equation by 6 in order for me to cancel that out. So let me multiply here by 6 and 6, which means that changes the enthalpy from negative 74.8. I'm going to multiply that entire thing by 6, which will get me negative 74.8 times 6 will give me negative 448.8 kilojoules. That's okay. And what that does is that allows me to cross out, I have hydrogen chloride gas and hydrogen chloride gas, so I can cross these two guys out as well. And then finally, I have here, I'm reacting hydrochloric acid and it's producing hydrochloric acid, right? I have 6 of these and 6 of these. So all I'm left here in the red is I have 2 MS, which is good, the main reaction, plus 3 chlorines, so 3 chlorine gases. It's going to make by 2 MCl3. Everything else is crossed out. So this is Hess's law. So that's what we did there. So this is perfect in terms of our reactions balancing out. And what I'm left with all these enthalpies, right? I have all these changed enthalpies here. So for the first one here, the first reaction, I didn't do anything to this reaction here. So this here is still negative 569, right? Negative 569 kilojoules. What I'm going to do is I have to add up all the enthalpies here, right? So again, I'm going to erase this. This is simply just 910 kilojoules. So this is 910, 910 kilojoules, and I multiply this by 2 here. So in the second equation, I multiplied everything by 6 here, right? Everything's here by 6, so I got negative 448, right? I have this enthalpy multiplied by 6, I would get this number here. The third equation, I multiplied everything by 3, right? Everything by 3 gave me, was so I would multiply the entire enthalpy here by 3. I'd get this number here. And then lastly, what I did here was I flipped the equation so I have to multiply it by -1. So this here became, instead of negative 405, it became positive 405, and I also multiplied it by 2, right? So I can cancel out the 2 MCL3 in the aqueous form and the 2 MCL3 in the aqueous form here. So that's signified by this 2 here. So I can add all of these enthalpies up to get the enthalpy of my reaction for the first one, right? So let's add this up. So it's negative 569 plus negative 448.8 plus negative 5,535 plus positive 910, which would finally give me an enthalpy of a reaction, which is negative 5,642.8 kilojoules. So this will be my delta H for the main reaction, which was this one over here. So let's look at our, so this was our answer here. So let's look at our solution. So they, it's a very, very long solution like I did before. So they said the user has to law for enthalpy changes, 2 m's to the left. So equation 1 remains the same. Good. We need to cancel out, let me look at this. We need to cancel out HCl. So we have to multiply the equation by 6, and that's what they did here. Then, so they would get this here. They add both equations to get this. We cancel out common terms, cancel HCl and H2. Equation 3 is multiplied by 3. That's great. And they added both equations. They canceled the common terms. And now we need MCl3 in solid state, not aqueous. So we, for equation 4, they inverted it, which is good, and they multiplied by 2, right? So that's what they did here. And then they added up all the enthalpies to get 5,742.8. I think they're off by 1 here. Or am I off by 1? I got 5,742. I have 5,642. So let's see. Are they off by 1? Or did I copy something wrong here? Negative 569, that's good. Negative 774.8. 1,845 and negative 405. I believe I multiplied everything correctly here. Multiplied by 6, multiplied by 3, and then multiplied by -1 and 2, right? So I think their problem's actually off by 100. So let me just double check their math here. I'm gonna double check this guy here. So 6,552 plus 810 will give me negative 5,742. Oh, yes. So my math is wrong. Sorry. My math is wrong here. I see what I did wrong. It's this problem here. Negative 405 times -1 times 2 here would give me a value of 810, not 910, which means the answer here was correct. 810 kilojoules, which means this 5 becomes a 7 when I added it all up. So that here is our final equation. So I actually did my math wrong here. I did negative 400. I didn't use a calculator for this, so of course, silly me. 405 times 2 here is 810 here. Negative 405 times -1 times positive 2 is 810 kilojoules, which is the correct answer. So this here is a correct solution. Perfect solution and analysis. My bad for that. Sorry, guys.